Welcome to a Scott Equipment Company Automation Simplified video for Tolomatic online sizing software. One of the things about working here at Scott Equipment, which is really fun, is me and the rest of the tech team, we get to spend a lot of time trying to size up a variety of electric actuators, from ball screws, belt drives, linear motors, even rotors and grippers. But one of the ones that's really a lot of fun to work with here under our manufacturers is Tolomatic. Let me scroll down to that, and we're going to dive into their website, and I'm going to show you their online sizing software. Here we go. So here on their website, you'll see under support, if you go over here to the left, you'll see electric actuator sizing. Now, when we go here, I'm already logged in for convenience, but you may have to create a profile and log in. But one thing before I dive into the software I want to show you is what's called the pipeline. If you click on this, it shows you all the different electric actuator sizing examples that you've already worked on. So if you need to go back and revisit one for a specific customer, or you want to make a change to one that you're sizing up for someone for an application, this is a very convenient way to do that, which often gets overlooked. So if we go back now to where I was for the sizing, I'm going to click on Start a New Project. So here, there's some fields you can obviously fill in with information like whatever the project is for the customer or the individual. You can put specifics about the application, like how long of a stroke, how heavy of a payload, the operating environment, orientation, things like that, just for convenience. But now we're just answering questions. So here I have the option of doing a rod style, like a ball screw, or I can do a rodless, such as a belt drive actuator. We're going to go ahead and select rod and guided rod because I specifically want to use an ERD for this application. And I'm going to specify a 10-inch actuator. And by the way, before I go any farther, you have the choice of choosing metric or English. I'm just going to leave it as English, which is the default. Also over here, you see Tolomatic motor, which is default. There's also an option for third-party motor. Now, I'm going to leave this on Tolomatic for right now. I want to show you what that particular portion of the actuator sizing software looks like when we get to it, but we are going to change to a third-party motor in just a moment. Here for the motor mount, we have the option of doing either what's called reverse parallel, or we can actually have a 2-to-1 gear reduction built in if we need that. So this will be a reverse parallel or foldback design actuator versus one like this, which is where the motor is in line with the ball screw. This one actually happens to have some built-in guides for deflection, things like that. So we're going to go ahead and select both. And also now it's asking for orientation. I'm going to select horizontal because I know that's how the customer intends to orient this particular actuator in this application we're trying to solve. And I'm going to also click on unknown or NA for the application environment. That's something we can circle back to later if we need to, if there's some harsh conditions or maybe there's some ingress protection we need to consider in regards to actually getting an actuator that will last for a long time in the application in question. So I'm going to continue to the next step. And here, I'm creating my actual motion profile. Now, one little quick tip is that while I could go ahead and create a profile that goes out, has a dwell, comes back, what you really want to do is size up the electric actuator for the worst case part of the application. In most cases, that's going to be the extend, where you actually have a payload on the end of the thrust tube or the ball screw, and maybe some additional forces. So what we're going to do first is we're going to do our worst case scenario profile. I'm going to call that profile 1. We're going to make this one 8 inches, and I'm going to try to make this move in a half a second. Right? You have the option of, as opposed to selecting your time that you want to make the move in, you can also select a predetermined speed if that's really how you're trying to size up this one. It's either or. You can also check between whether you want a triangular shaped extender track profile or a traditional trapezoidal shape, which is what we're going to leave it at for the time being. So we're going to, it's going to be forward away from the motor. We're going to add that velocity profile. And there you see it, an extend, constant speed, and then a dwell as it decelerates back to complete the move. And what we're going to do next is we're going to add a load. Now the load would be what's actually attached to the end of the transition plate, which is what's attached to the end of the thrust tube or the ball screw of the actuator, right? Could be your fixturing, it could be the fixturing and the actual load, the item you're picking up, if that's the case. In this case, we just have a gripper type apparatus to hold apart. So we're going to call that load, let's see, we're going to call it 5 pounds. The customer actually said 2 kilograms, which is about 4.5 pounds. We're gonna call that about 5 pounds. And also, as far as for moment prevention and understanding like where the center of gravity of the payload is relative to the axis of the actuator itself, there's an X, Y, and a Z coordinate we want to consider. In this case, since we're just pushing on something along that what we call the X axis, I'm going to go down here and I'm going to call this center of gravity of the actual payload attached to the transition plate or thrust tube of the actuator. We're going to call that about 2 inches, okay? Off that center line away from the axis. So and right now I'm going to leave this supported by actuator at 100%. We're going to circle back to this in a second. You're going to better understand why. I'm going to add this load. And the customer also told me there was an additional force. So at the end of this worst case scenario move, there's a bit of a force applied pushing back on the thrust tube of the actuator, which he says is about 10 pounds. So we're also going to add this force. And we're also going to call it in the X axis, and we're going to call that 10 pounds. And as far as the center of that applied force, we're going to use that same 2 inches, as that's where it's going to attach to the transition plate of the ball screw itself. And we're going to add that force effect. So now we have the motion profile, we have a load, and we have a force. And I made a mistake. Oh. So we want to, I know what I did wrong. So what I need to do here is I forgot to attach the payload and the force to that motion profile. You do that by this checkbox here, which is another little gotcha. This is one of the things I often overlook when I'm sizing up an actuator with Tolomatic sizing software. But again, it prompted me to let me know I forgot to do this one simple step. So I'm going to edit that load and add that. And I'm going to go down to the force and do the exact same thing. Let's edit that one. And you'll see here, I've neglected to check this box, which lets me know that force is also applied to that extend profile. Now, so we're going to edit that, and now we look good. So let's continue to the next step. Selecting and deselecting, you truly filter out those as options. So we're now only going to see ERDs. Furthermore, I can select whether or not I want to, say, not look at an ERD 10, for example. But again, we're going to circle back to something. So I just want to show you all that real quick, and we're going to continue to the next step. And I want you to see what happens. So here on this page, this is where we're talking about the Tolomatic motor versus a non-Tolomatic solution. So if I wanted to use Tolomatic's popular ACS drive with one of their servo or stepper motors, which comes in a variety of flavors. I have Ethernet IP, I have Modbus TCP, and I also have Profinet as options for protocols for this controller to interface it or integrate it back to a PLC. But for the sake of this application, I would want to do a non-Tolomatic solution, right? And more on that in a moment. So let's go ahead and click on continue to the next step, and I want to show you what happens. Just looking for actuators, and it says there are none available to solve this application, which I know is not true, but I made another little mistake. So if I go back to the motion profile, and this is something that often is overlooked by customers who are using their online sizing software. Here under the load, I mentioned that I had, let me go back to edit. I had said 100% of this payload, this 10 pounds, is supported by the actuator. I can always add something like a high wind rail or some additional guide to offload that support, so the actuator is not asked to do that work. We're going to do that here, and I want to show you what a difference that makes. So we're going to presume that we're going to use, again, a high wind rail to support this payload, be parallel with the axis in motion, and we're going to now, let's click on edit that load to save it, and now let's click on continue to the next step. And once again, I'm going to select and deselect these because I just need to again. Otherwise, it may give you some of these solutions. And I'm going to go ahead and deselect the ERD10 and the 15 because I know it might give me ERD15, but I don't think I want one of those. It's just a little too small for this application because of the forces. So I'm going to continue to the next step. Now, it's asking me again about what kind of motor I want, and I'm going to keep it a non-Tolomatic motor. Now, let's see what pops up under selection results. Look at that. We have ERD20s through ERD22 with some high thrust options. So one thing you can see on this page is this is showing you from the least expensive down to a more expensive solution that all work in order. So I know off the top of the page here, this will be the least expensive solution which would actually work. But let's look down here at one of the bigger ones. So let's look at the motor spec tab. So here it's showing me for that particular, when I selected or highlighted yellow, it's telling me the peak motor speed, the continuous motor speed, the peak torque, continuous torque, the reflected inertia of this application. So I would know how to size up a servo motor correctly to make sure it's going to work and optimize it for the application. So I'm going to close that. And I also want to show you these other two areas. So the screw belt critical speed, you can see in the one I've selected, the speed is it's right on the threshold actually. If we were asked to do this thing any faster, it probably wouldn't even give us this actuator as a solution. So I know that would be a bad one, but I just wanted to show you that as an example. Also look at the screw belt force, and we see the force is well within the tolerance for that particular actuator I have highlighted yellow. But again, for this application, I feel very confident that I could use this ERD20 at the top of the list, which happens to be the least expensive. And quickly, we'll look at the motor specs for that one. You'll see here, I got some very doable motor speeds and forces and torques I've got to accommodate, so it shouldn't be a problem. If I look at the screw belt critical speed, that black dot represents I'm well within this red curve for that particular motor, for this particular actuator. And as far as screw belt force, again, I'm well within a potential force. So I've got plenty of overhead, plenty of safety factor if I pick this particular actuator. So let's continue to the next step. And now we're getting to the Your Motor Here aspect of Tolomatic's online sizing software, which we're a big fan of here at Scott Equipment Company. So I can select Your Motor Here, submit. Now, if I click this drop-down menu, I'll see Allen Bradley or Rockwell. I'll see Baldor. I see Emerson. I see GE Fanuc, Kollmorgen. Long list. I see Apex gearboxes. I see Yaskawa servo motors, JVL servo motors, which we have here. The list goes on, right? Siemens, GAM gearboxes, Omron, and so on and so on. So what I want to do here, because again, as I mentioned, we are big fans of JVL servo technology and stepper technology. I'm going to select JVL, click submit. Now it's asking me, okay, well, which JVL series do you want to adapt to this particular actuator? I want to use the Max series. Select that one, click submit. Now it's asking me, in the Max series, which particular servo controller and motor do we want to use? We use a lot of the Mac 400s here. We actually keep them in stock at Scott Equipment Company here in Charlotte. So I'm going to select that one, click submit. And now it's asking me, hey, how do you want to mount the actuator? I have the option of clevis mount, trunnion mount. I'm going to go ahead and select foot mount for this particular application because that's how I think I'm going to need to mount it. And it's showing me here an entire part number, ERD20 with a 20 lead ball nut in metric. Show me the stroke length, which is the metric version of, I think, the 10 inches I selected. The LMI means it's inline. This YM, it means it has an adapter which comes on the actuator for a JVL Mac 400 servo motor. Makes it real easy. Now, let's continue to the last step. And here it's showing me a list price for this product. It's showing me all the nuances of this solution, including inline. It's showing me the lead of the screw. It's showing me a part number. It's telling me down here that I can do things like I can print out a full sizing report. That sizing report is going to give you things like the profile you selected, the speeds and feeds, as well as those curves to let you know how much safety factor you've got for this particular application. So that's pretty much it. You can, from here, you can print this out. If I need to omit that pricing, maybe I'm going to send this to a customer, right? And maybe I've got my own special pricing we're going to attach to this, and, but I don't want that to show. So you have a lot of options here about how to finalize this report and save that, so you've got a copy of all the work you've done. And it's also in the pipeline as well. So if I save this file here under Save, right, and go back to the pipeline, once the pipeline updates, this new application will show up in the pipeline under Scott Equipment Company. So it makes it real easy for us to continue to work on electric actuator solutions for customers using Tolomatic's products. So hopefully you enjoyed our time going over this expose on Tolomatic's online sizing software. It's one of those things that once you use it, you will find it very useful as far as determining how to size up a ball screw or even a belt drive Tolomatic actuator to solve your particular application.